So we're going to continue here with quadratic functions. This is modeling, they call it. You can write equations of quadratic functions using vertices, points, and x-intercepts. I can write quadratic equations to model data sets. I can use technology to find a quadratic model for a set of data. Okay? So today we're basically doing the first bullet point there. Given vertice and a point, we can write the equation using vertex form. If we got the x-intercepts, we can write the equation using intercept form. Okay? So here's the two forms again for review. All right? Remember, and here's where some of us messed up the other day. If it's in vertex form, this number here, this h value and this k value, that's the vertex. Okay? And it was basically the opposite of that, right? What makes that 0? Right, so if it was an x minus 2, the x value of the vertex is positive 2. If it's an x plus 2 there, then the x value of the vertex would have been a minus 2 or a negative 2. Okay? And whatever number's out here, plus or minus k, it just stayed. That's the sign of it too. That's the y value of the vertex. Okay? So you should be able to do that. Okay? When it's in intercept form, this x minus p and x minus q is like this x minus h. X minus p, the p value, like if it's x minus 2, the one of the x-intercepts, the p value is positive 2. If it's x plus 2, then the p value is negative 2. If it's x plus 3 here for the, instead of x minus, right here for the q, x plus 3, so then the q would be negative 3. Okay, so, and the y value for both of those is 0. Anytime you're on the x-axis, the y value is 0, those x-intercepts. Okay, so we're going to substitute basically into those two forms to find the equation of the quadratic. All right, that's what we're doing. We're just plugging into that equation, either one of those. All right, so here's example 1. It says write equation of the parabola in vertex form. Okay, so again, we should have this down now, but if you don't, write it for yourself. Put it at the top of your paper. Have your notes with you. All right, so y equals a x minus h squared plus k. This is the one we're using, okay, because they gave us a vertex and a point. All right, and we're just going to substitute in. All right, so remember, when we have a point, this is the x value, that's the y value. It's called an ordered pair, right? It's in alphabetical order. The first number is the x value, the second number is the y value. All right, vertex, again, the negative 2 is the x, the 5 is the y, but in our formula, or our vertex form, it's h and k. All right, so I'm just going to substitute -7 for y. Let's do this, color code it to help you. All right, we're going to use green 1 for the x. Okay, h is -2. Plus k, we'll use purple. Okay, Just substitute in. Well, what is minus a negative 2? This is addition, right? So we can go back to the black now. So negative 7 equals A. What's 1 plus 2? 3, right? Plus 5. Okay, so how do I solve for A here? What do I got to do now? Oh, I forgot the square. You're right. Thank you. So I should simplify here. 3 squared is 9, right? Here's what we're used to seeing, right? How do I solve for A? Taylor? Good. Subtract 5 first. So I get negative 12. Cindy, what do I do now? Divide by 9. Good. You guys all know this, right? So that reduces to, what numbers goes into 12 and 9? 3. What's negative 12 divided by 3? Negative 4. What's 9 divided by 3, right? All right, now I know what A is. So is this parabola, if I were to graph it, you don't have to, but if I were, does it open up or down? Down. Why? By A value is what then? Negative 4/3. Yeah, negative 4/3, right? So when it's negative A value. So now let's substitute, what we know in here for the equation. We're going to substitute what we know for H and K and A now to write the equation. All right, so it's Y equals A. We just figured that out. X minus H was a negative 2, so what happens in there? We did it as we were solving it. It actually becomes X plus 2 squared plus 5. That is the equation of that quadratic, or of the parabola, however you want to call it, that has a vertex negative 2, 5, and passes through 1, negative 7. So if I wanted to graph that, just to show you, let's see if I can get a graph up there for you. So hopefully this will help you visualize what's going on here. All right, so what was our vertex? Negative 2, 5, wasn't it? Yeah. Okay. Negative 2, 1, 2, 3, 4, 5. So there's my vertex. Pass through what? Was it 1, negative 7? Is that what I had? I'll go back up. Or 1, 7. Yeah, 1, negative 7. Negative 2, 5, 1, negative 7. 1, 1, 2, 3, 4, 5, 6, 7. All right? So, here's my axis of symmetry, right? Going down this way. So I go left, how many? Thanks, you guys. Oh, I missed it. That's why you guys weren't telling me the right answer, were you? Because I messed up. Yep, you guys are. All right, so I got to go left how many? 3 spots, yeah. Sorry about that. Okay, so, just a quick. So let's see if we go to our calculator and put in what we decided the answer was. That's what we said the answer was, right? Negative 4/3 x plus 2 squared plus 5, right? Hit enter, hit graph. Does that look like the one we drew? Yeah. Mine's a little bit messier, right? Okay. Questions? Questions on what we did there? Understand where we're substituting what numbers. Okay? Remember, the vertex x and y go for h and k. The point it passes through goes for the x and y in your vertex form, so we can solve for a. And once we know what a is, we can write our equation. We're just plugging in and doing some algebra, right? Stuff you can handle. Jordan, how do I start this one?
You read it.
Good. So everybody read it while Jordan's reading it. Then she's going to tell us how to start.
You find the H and the K value.
Yeah, what is the H and the K?
0 and 50 and 35.
Yeah.
Okay.
50 and 35 is the HK, right? What's the point it passes through? You're good, Jordan, going good.
0, 15.
Correct. Okay? So we need to find the equation first, and then we got to figure out how high the net is, right? This person got shot out of a cannon, right? Circus performer, right? Okay, so over here at this point, we're looking for this point here, basically, right? What's the x value of this point? 90, right? To answer the question, we're looking for that number, right? Before I can find that number, we have to find that a value. So we're going to use the point they give us, the y-intercept there, 0, 15, and the vertex, 50, 35, just like we did in the last problem. Okay? So y, 15, equals a, that's what we're looking for, x, 0, the point we're using, minus h, 50, squared, plus k, 35. That make sense? Questions on how we got to here? Nick, making sense? Okay, just substituting in. All right, so do what's in parentheses first. What's 0 minus 50? Negative 50. And then we got to square that. So what's negative 50 times negative 50? 2,500. I like to put it in front just so it looks like we're used to seeing. All right, so we'll subtract 35. And we get negative 20. And then divide by 2,500. And you can use a decimal if you want for the a value. Our a is going to be negative. Is that what we expected to happen? Why, Cole? Because it's opening down, right? And then in our calculator, we'll just go negative 20 divided by 2,500 You can leave it like that, or if you want to change it to a fraction. I don't know if I've showed you this before, but you hit the math button, just hit enter twice now, and it's changing the decimal to a fraction. So it's negative 1 over 125. You can write it either way. We'll use the decimal this time. So our equation is y equals negative 0.008 x minus 50 squared plus 35. You okay with my equation? Now we have to answer the question. We're looking for this height of the net where it catches the person that got shot out of the cannon. All right, so we're looking for that question mark there. So what's my x value? 90. You understand why it's 90? You know, in the problem it said the performer lands in a net 90 feet from the cannon. Or if you're looking at the picture, here's our horizontal distance. You know, these are going 10, 20, 30, 40, 50, 60, 70, 80, and there's, it's on that 90 line, right, for x. So that's where that is. So we're going to put 90 in that spot. And then whatever we get, after we substitute that 90 in for x, will be, excuse me, how high that net is up in the air. So negative 0.008 times, what is 90 minus 50? 40 squared plus 35. 22.2 feet high. Okay? And if we look at the picture, these are going by what? 5, 10, 15, 20, 25. So that looks about, you know, where that is, looks like about 22, right? So it's making sense, our answer, right? Questions? You understand? Is this that difficult for you guys? Okay. Example 3. Write equation of the parabola that passes through point 25 and has x-intercepts of negative 2 and 4. Okay? So, remember, x-intercepts means the y value is 0. So that's what the points are, if you need to write this. That helps you. Okay? Okay, so we're going to use the other formula. This one for the intercepts now, because they're giving us intercepts. Y equals a, and then x minus p and x minus q. That's the one we're going to use. And do the same thing we've been doing. All right, so here's our equation. We're going to have to figure out the a value. Okay, remember the p and the q are your intercepts. Okay, and then our point, 2, 5, so I put a 5 in for y from the point. We're looking for a. X is 2 for both of these. 2 minus, actually, it's, and then the p is negative 2, and the q is 4. Questions on how it's always x minus, and then if it's a negative, what ends up happening? Turns into plus, right? So my a value will be 5 equals a times 4 times negative 2, which would be 5 equals negative 8a. Divide by negative 8. So we have another a value that's negative. So it's going to be a parabola that opens down if we had to graph it. So let's write our equation then. A we figured out to be negative 5/8. And then it's x minus negative 2, which is plus 2. And x minus 4. In intercept form. Questions? Again, we need to stay focused and ask questions now if you don't understand. That's what we're here for, to help each other out, right? But once we plug the numbers in, it's pretty easy, right? Again, just taking our time, using our algebra skills to solve. And then plug back in. Okay? Questions? Okay. Spencer, you read along with everybody else and then tell us what we got to do.
Would you use the x-intercept?
Why are we using the x-intercept?
We have two x-intercepts.
Right, we got the two intercepts, the 4, 0 and the 24, 0, right? We have a point, the 0, 9.6. All right, what are we looking for, Spencer? When we're looking for what is the coldest temperature?
Wait, what do you mean by that?
Yeah, I mean, what number, once we get an equation using the intercepts, what are we going to have to do to answer the question? Because we're looking for the coldest temperature. Find the vertex. You guys understand that? The vertex is the furthest down, right? The lowest point. So that'd be the coldest temperature, right? So we're looking for this point down here, which looks about right there, right? And we're looking for the y value, right? The y value tells us the temperature. So this is actually what we're looking for. What's the x value going to be? How do we figure that out when we have the intercepts? What do we do? We're supposed to do on the quiz Friday. Good, Vince. Supposed to go 4 plus 24, add the 2 together, and divide by 2. What's 28 divided by 2? 14, right? So we know the x value of the vertex 14. What we're going to do is figure out the a value again. And then we're going to plug 14 in for x to find the y value of the vertex. You understand the procedure we're going to do? Does that make sense? All right, so we got to do our y equals x minus, oops, what did I forget? Forgot my a. All right, y equals a, x minus b, x minus q. All right, so we're going to use this point for x and y. So 9.6 a. We're going to use 0 for x. And then remember, 4 and 24 is our p and our q. You with me? So we get 9.6 equals a times negative 4 times negative 24, which is positive 96, which let's put it in front like we're used to seeing. Somebody check me, but I think 4 times 24 is 96. All right, what am I doing with the 96? Divided, right? And that comes out to what, 1/10, I think, 0.1? Mason, is that right? 9.6 divided by 96.1? Yeah, the other one, I was right, that one, right? Do 9.6 divided by 96. Right, so 1/10 or 0.1. You can use the decimal if you want. So here's my equation. Y equals 0.1 x minus 4 and x minus 24. Okay? Now we just said, what are we going to use for x? Right? Because we found the axis of symmetry, right? By adding the two x-intercepts and dividing by 2. That's just cutting it in half, right? Because it's symmetrical. All right? So, 0.1, 14 minus 4, and 14 minus 24. All right, so that's 0.1 times 10 times negative 10, which equals negative 10. So, what's the coldest temperature? Negative 10 degrees Celsius. AJ?
Would you just be able to look at the graph and answer that?
Yeah, you could. But we have to find, basically what they want us to do is practice finding the equation of the quadratic, but you are correct. Yeah, common sense, right, AJ? So what we would do is use the picture to help us check to see if we did it right. All right? Do these examples make sense? That's all we're doing tonight, those types of problems. Finding the equation of your parabola. They're going to give you vertex and a point, or the x-intercepts and a point, okay? No questions? Cool. There you go, page 76, 2 to 12 even. I gave you some time. Use it wisely.